In this content, we will look at the stealth technology of the F-35, the radar-absorbing material behind it, and its planned-formed alignment and engineering. We will try to explain the basic differences between the F-35A B and C, examining the engineering of STOVL or short takeoff vertical landing and the engine powering it, and how it works in simple animation. As a fifth-generation fighter jet, we have to look at the weapons system, as well as the electronic warfare suite, and last but not the least, the $400,000 helmet and its features. Now, leaving politics aside, let's get straight to the content. This is the Lockheed Martin F-35 Lightning II. The search for a stealth fighter that can take off and land in tight confines has lasted decades. Lockheed Martin began developing experimental vertical rising fighters as early as 1954. The Harrier was one such aircraft that had achieved this engineering feat. Its technology was ahead of its time, but it has its flaws like every engineering marvel. During vertical landing, it would turn over multiple times due to turbulence from its own downwash. On the tip of each wing included a small roll control nozzle which had to be controlled manually by the pilot to stabilize the aircraft for safe landing. However, the F-35B short takeoff and vertical landing system, STOVL, was an improvement, combining vertical landing with long-range supersonic speed, resulting in a stealthy, lightning-fast fighter capable of carrying modern weaponry. Let us look at the variants of the F-35 along with their differences. There are three variants, all of which are single-seat jets. The F-35A, which is a conventional takeoff and landing variant, was designed for use by the United States Air Force and numerous allied nations. This aircraft was designed to operate from standard airstrips and is the sole F-35 with a 25mm internal cannon, allowing it to replace the F-16 multirole fighter and the Flying Cannon A-10 Thunderbolt II, among other aircraft. This cannon is not available on the other variants. The F-35B was developed specifically for short takeoff and vertical landing operations and was built to meet the requirements of the U.S. Marine Corps. The F-35B's takeoff and landing capabilities allows Marines to operate these jets from short runways or off the decks of amphibious assault ships while still being able to operate from standard runways. The F-35C is the first stealth fighter developed specifically for U.S. Navy carrier operations. It has longer wings than its rivals, allowing it to land at a slower speed on a carrier. It has more robust landing gear to help with difficult carrier landings, and it has a greater internal fuel supply, 9,072 liters, to support longer-range missions. This variant has the added mechanical feature of foldable wings, which makes it easier to store in ship hulls. For now, we will look at the F-35B and its specifications. The F-35B has a length of 51.2 feet and a height of 14.3 feet. A wingspan of 35 feet, which helps to maneuver the plane in a planned-formed alignment. The jet has an empty weight of 14,729 kilograms, which is equivalent to the weight of 17 Jeeps. It has a weapons payload of 6,800 kilograms, which we will talk about it in more details later. Now that we have seen the dimensions, let us look at the basic parts of the fighter jet. This is the nose of the F-35, and inside it is a Northrop Grumman AN/APG-81 active electronically scanned array fire control radar, which is the world's most modern and capable radar, and serves as the backbone of the F-35 Lightning Advanced Sensor Suite. Moving back, we have the canopy, which has been plated with an indium tin oxide layer to give it a golden sheen. This helps to keep it stealthy. This is the lift fan doors of the F-35. Inside it is a Rolls-Royce lift system that offers a STOVL short takeoff and vertical landing aircraft that is exceptionally durable and dependable. The Rolls-Royce lift fan is the heart of the F-35B's thrust vectoring capability. 29,000 shaft horsepower is delivered to the lift fan. The exhaust nozzle, which is connected to the main engine by a drive shaft, produces a downward flowing column of air at the front of the plane. At the back, the exhaust nozzle twists, aiming its push toward the ground for directional control. All of this is possible because of the Pratt & Whitney F135 afterburning turbofan engine. It comes in two versions: a conventional takeoff and landing CTOL type used in the F-35A and F-35C, and a two-cycle short takeoff vertical landing STOVL model with a forward lift fan used in the F-35B. Let's look at how this works. Air is sucked from both the rectangular intake ramp and fuel is sprayed into a segment of the jet pipe, where it mixes with the exhaust gas and ignites, resulting in a second stage of combustion. In order to save jet fuel, during takeoff, altitude ascent, or battle maneuvers, the afterburner is only employed in short bursts. The exhaust nozzle is made up of petals and is designed to narrow or enlarge the distance between them. This is done to lessen the strain on the turbofan engines when they are in full afterburning mode. All that power is being fed by the massive number of 7 to 10 internal fuel tanks. Let us look at where they are placed. Fuel tank number 1 is located just behind the pilot seat. This is the fuel tank number 2, also known as center fuselage. This is fuel tank number 3, also known as engine feed tank. Moving back, we have wing carry-through, which fuel tank number 4, along with 2 fuselage vent tanks. On the wings are 2 massive fuel tanks on each side, also known as the wing fuel tank. 2 more vertical fin vent tanks are located on the fins of the aircraft. Now let us look at the parts of the wing. 2 rudders are located just above the tail fuselage. The 2 massive elevators are located further down. The lifting force can be decreased and appropriately increased since the ailerons have the ability to move up and down, while the rudders assist in moving the plane left or right. This is the elevators, which may be modified to make the aircraft move up or down. Check out our last video on how the wings work with the control surface in a very basic explanation, the F/A-18 Super Hornet. As the name suggests, stealth fighter, let us look at how it was able to avoid most of the radar. Believe it or not, the shaping of the F-35 provides most of its stealth technology. This is known as plan-formed alignment. This improved flight design orients key flight surfaces at the same angle. As a result, radar energy is scattered away from the plane rather than diffusing it, where it could still potentially be detected. This plan-formed alignment has to be built from the ground up. The radar paint technology is still classified, but this is what we know from aviation experts, and what we learned is they used a radar-absorbing material. RAM is a type of polymer-based material that is put to the surface of stealth military aircraft like the F-22 Raptor and F-35 Lightning II. This reduces radar cross-section and thus making them more difficult to detect by radar. Stealth with low visibility. The F-35's aligned edges, decreased engine signature, internal weapon and fuel carriage, and embedded sensors all contribute to its exceptional stealth. The F-35 has an unrivaled ability to elude adversary detection and enter contested airspace thanks to its stealth design from the start. Complementing the stealth technology are these hidden pieces of engineering. The ANASQ-239 electronic suite is at the heart of the F-35's electronic warfare system, a modular system that provides both defensive and offensive capabilities, ranging from the detection of hostile emitters to threat geolocation to the automated release of countermeasures, infrared flares, or radar-reflecting chaff. Now let us look at the weapons capability of the F-35 stealth fighter. This is the electro-optical targeting system. This improves situational awareness for F-35 pilots and enables aircrews to identify points of interest, conduct reconnaissance, and precisely launch laser and GPS-guided munitions. It is the first sensor to integrate forward-looking infrared and infrared search and track functions. The F-35 carries weaponry internally in stealth mode or externally in a permissive environment in a situation where they don't expect to have any threats to their safety from hostile forces. Externally, the JASM will be carried by all variants of the F-35, enhancing reach, lethality, and survivability against heavily defended strategic targets, and increasing the ability to deter near-peer adversaries. Lockheed Martin created the AGM-158 JASM, Joint Air-to-Surface Standoff Missile, a low-observable standoff air-launched cruise missile for the American Armed Forces. It is a substantial covert long-range weapon with an armor-piercing warhead weighing 450 kilograms or 1,000 pounds. The AIM-120 AMRAAM can be carried by the inboard station. Flares, chaff, and towed decoys are stored in 2 compartments behind the armament bays. The F-35 features 2 internal weapons bays with 4 weapon stations to maintain its stealth shape. The 2 outboard weapon stations can each carry 2,500 pounds of ordnance, or 1,500 pounds for the F-35B, while the 2 inboard weapon stations can carry air-to-air missiles. The Joint Direct Attack Munition, JDAM, Paveway series of bombs, Joint Standoff Weapon, JSO, and cluster munitions are all air-to-surface weaponry for the outboard station. Now let us look at the $400,000 helmet. This is the helmet-mounted display, which gives the pilot critical flight information and sent directly to the visors. This is the integrated digital night vision device. The helmet is fed with data feed, which displays imagery from a set of 6 cameras mounted on the F-35 airframe, which moves along with the head of the pilot. The helmet also provides information about target identity and distance, and even recommends which weapon to use, so when looking through the plane, if the pilot sees something that should be hit by a missile or just wants a closer look, all he has to do is look at it to lock on, then flip a switch to zoom in. The pilot can therefore see straight through their own body and the floor of the plane to the terrain below. Do support your small content creators as we bring out videos like these. Let's grow together and hit the 1 million subscriber mark.